We have another example on the board. I want you to remember that anytime we use the method of completing the square, we're supposed to have the second degree term and first degree term on one side, and constant is going to be on the other side. I prefer to have the second degree and first degree term on the left side. That's why I'm going to most of the time move them to the left side, and I'm going to have 25a squared minus 15a equals 18. Next, very important thing is to have coefficient of the second degree term equals to positive 1. In order to get so, we have to divide every single term by 25. Okay, so I'm going to have 25, 25, and 25. I have a squared minus, now please notice that 25 and 15 are divisible by 5. That's why I'm going to reduce this fraction right away. I'm going to have 3a over 5 equals 18 over 25. Next, please notice that at this moment we have invisible 1, okay, at the front of my second degree term. So this is the perfect condition to keep going with the completing the square. So what am I supposed to do next? Copy a squared minus, copy the first degree term, 3 over 5a plus, now we're supposed to take 3 over 5 and divide by 2, because the coefficient of the first degree term has to be divided by 2 and raised to the second power, equals 18 over 25 plus whatever we add to the left side. So we add 3 over 5, everything over 2 to the second power. Now, but this expression looks kind of ugly, so we have to fix this a little bit. Because we have fraction in the numerator, I'm going to make fraction also in the denominator. Remember, anytime we divide fractions, we're supposed to copy down the first fraction and division change to the multiplication, and second fraction has to be flipped upside down. We have to find the reciprocal of the second fraction. That's why I'm going to have 3 over 5 times 1 over 2. Okay, I performed just the division of these two fractions. So I have 3 over 10, right? So instead of writing two fractions divided by themselves, I'm going to simply write 3 over 10. So I have a squared minus 3 over 5a plus 3 over 10 squared equals 18 over 25 plus 3 over 10 squared. What we can do now? Simply copy down a minus 3 over 10 to the second power. One more time. Copy down a, copy down this negative sign. The sign which you will always copy down is the sign between the second degree term and first degree term, and copy the base of this expression, okay? And we have on the right side 18 over 25 plus 9 over 100. Because 3 to the second power is equal 9 and 10 to the second power is equal 100. Please notice that we have fractions on the right side. So we have to find a common denominator in order to add them up. The common denominator for these two fractions is going to be 100. That's why I have to multiply 25 by 4. Whatever I did in the denominator, I have to do also in the numerator. I'm going to copy down the left side, and I have a minus 3 over 10 to the second power equals 18 times 4 is equal 72 over 100 plus 9 over 100. I have a minus 3 over 10 to the second power equals 72 plus 9 is equal 81 over 100. Next, in order to find a, I have to square root both sides of the equation, and I'm going to have a minus 3 over 10 equals plus minus square root of 81 over 100. I want to separate a. That's why I'm going to move negative 3 over 10 to the right side. I have a equals 3 over 10 plus minus, and square root of 81 is equal 9, and square root of 100 is equal 10. So I can say that a equals 3 over 10 plus 9 over 10, which is equal 3 plus 9 is equal 12 over 10, and this is equal simply 6 over 5, and I have a equals 3 over 10 minus 9 over 10, which is equal 6, of course negative, over 10, negative 6 over 10. If you are going to reduce this fraction by 2, you are going to end up with negative 3 over 5. And I can say that these are the solutions to my problem.